you see a problem or there's no problem?
No problem.
No problem.
No problem.
We are assuming that each cell is P of x comma y.
That is okay. See, I'm not assuming here. Don't say assume. P star is this. If I say this statement, is it a valid distribution or not? That's all is my question. If it's valid, we can take it as an example. If it is not,
It's valid. It's valid.
Yes,
but some of you were saying
No,
if
I
I
think
write
it's not valid.
0.25 here, who is that who said it's not valid?
I said, I think we know x, what is the x value. We just need to
Okay.
find out the y value. So when I know
So,
x, right,
hmm.
the distribution is only between 0 and y, 0 and 1 of y.
No,
Or,
whatever you want to say, you say. But what should be? This is wrong. You are saying.
yeah,
So, what is the simple correction you will do? If I give you, if I ask you an example of P star and say that don't modify this matrix a lot, do a simple change. What will you do? This is just to understand your thinking. That's all.
okay. Maybe I'll make 0, 1 would be 0.75, 0.75.
7.5. Okay. So, how many of you agree with who is that who said 0.75?
Ram Mohan.
Okay. So, how many of you agree with Ram Mohan that 0.75 should be there? Suppose I fix this. I am not willing to change this value. This should be 0.75. How many of you think that is the case?
Then other two values should be 0, isn't it?
So what is your name?
My name is Anuran.
Ram Mohan.
No, my name is Anuran.
Anu?
Run.
Anuran.
Yes.
Oh, Anuran. Okay. So, Ram Mohan, Anuran is saying if you want to put 0.75 here, you should put these two 0. What will you react?
No, my assumption is that we know x value. So
See, I don't want assumptions here. I'm just asking you a simple question. What is a valid joint distribution? That's all, right? I'm not asking you any complicated question. Whatever I write here should be a valid joint distribution. So, is it valid or not is a discussion. Nothing to do with machine learning, nothing to do with assumptions. The definition of joint distribution is very clear, right? That's not ambiguous.
I think
then everything can be 0.25.
No, okay.
So he must be thinking that the matrix, like each row corresponds to the condition.
Right. And but why Ramohan? Why should each row add to 1?
The probability would be 1 only, right? So total. So that's why.
Yeah, but why is that a total? So why is that? See, what is the meaning of joint distribution? By the way, so all of this, don't think that I'm catching hold of Ramohan. I'm sure many of you will have such confusions. Okay, so please go back and revise probabilities. Okay, so you should have a thorough understanding of simple things. I'm not expecting advanced concepts. I'm not asking you to give a proof of Cauchy's inequality or give you a proof of how Markov inequality is tight or something like that. I'm not asking you anything even as moderate as that. I'm asking you to simply understand what is the definition of a random variable, its mass function, density function, cumulative density function, what are the properties they satisfy, what is the definition of expectation, then what is a multivariate random variable, again its density, mass function, distribution, things like that, expectations. Okay, so this is what is taught in section 2 of your Ross book. Okay, so please revise this thing and come to the next lecture. Okay, so at least section 2, 1 and 2 you should finish going through all the solved examples. The book I shared already.
Sheldon Ross, right?
Right, the one I sent an email about.
Okay.
And section 3 will talk about conditioning, which is the bread and butter for machine learning folks, right? So if you don't understand these concepts, then there's no way you can progress in machine learning, right? So please make a genuine effort, spend a lot of time. If you spend a lot of time covering your fundamentals, then believe me, at advanced stages, you will see its fruits. Now when things are easy, if you don't spend time, then later on it will become even more difficult to understand advanced concepts. So please do the corrective steps. A stitch in time saves 9, right? So you, all of you, I hope you understand the gravity of this saying, and please revise in time. Okay, so if something has to be a joint distribution, you have to define, the only condition is that all numbers should be greater than 0. I'm talking about discrete random variables here. So all these values should be greater than 0 and the value should add up to 1. That's all. Right? Those are the only two conditions. Right? There are no other conditions. Okay. Now, okay. So let's assume for the time being that it's a uniform probability kind of a case, right? So this is 0.25, 0.25. Okay. Okay. Now in that case, if I ask you what is what is the ideal f, what would you do? How would you answer this question?
So I would just make f generate 0 or 1 randomly with equal probability.
Okay. So if I do the following, suppose I say this is 0.9 and this is so 0.9, no, not 0.9, 0.4, and these are x values, right? So this is y values. So this is, so these are x values, 0.4 and say 0.6. Oh, sorry, 0.2 and 0.3, say, and then this is 0.3 and 0.2. Okay. Oh, now what will be your answer?
So 60, if you give me 0, 60% of the time I'll predict 1. And if
No,
you
no,
give me
see,
1,
I can't, no. See,
X1.
okay. You have to give
X1.
one value of, one value. You can't choose, this f is deterministic.
okay, then if you give me 0, I'll predict 1. If you give me 1, I'll predict 0.
So why?
Because if you generate a lot of samples, right, most of the time 1 would probably take 0. So by giving 0,
Should
I'll
you go into samples to answer this question?
no, if one because of
Prob-
probability 1 0 is more
Probability
likely.
of yeah.
See, you just asked this question, right? So you basically solve this optimization problem. What is the function whose probability of f of x not equal to y is minimum? That's all you'll ask. Yes or no?
Yes.
Right? So you'll basically ask, what is a function? How many functions are possible in this world? There are only 4 functions, right? There are only 4 functions, no? Because with 0 it is 1 or 0, 2 choices. With 1, 0 or 1, 2 choices. 4 functions, right?
Yes.
So out of these 4 functions, which function will I choose? If I ask, the correct answer is, already I know the probability distribution. So I'll basically solve this optimization problem. Okay. So to solve this optimization problem, what is the algorithm? Very simple. I don't even, so let me have placeholders. Suppose P1, P2, P3, P4. I don't even need to know those values. I'll get a general form solution, right? I can do that, but let's do it for this. So let's compute this probability first. So what is probability of f of x for a particular f, right? So let's take this f, which is, so what will I do? I will, let me take this f1, which is 0, 0 say, f1 of 1 is also 0. And now I'll ask the question, what is this? What is this? How many of you can tell me? So this is probability of f1 of 0, which is 0, right? Not equal to, which is defined as 0, right? Not equal to y. When is it not equal to y? When y is 1, right?
Yes.
Are you understanding? Yes, no?
Yes.
So this will be equal to probability of x being 0, and when x is 0, what is f1? 0. So y can't be 0, that means y is 1. Is this the only case? No, there is another outcome. What is it? X can be 1. In that case, what is f1? 0. So y can't be 1. So this is the thing. What is this equal to?
1.
What is it equal to? In terms of P1, P2, what is this equal to?
P2
P2 plus,
0.3.
plus
yeah, but let's write general forms. P2 plus
P4.
P4, right? So you're understanding, right? Like this, I can do it for every function, F2, F3, F4,
Yes.
and I'll then pick the minimum, right? That one, what is the guarantee you will have with that function? That function will encounter least error. Error in which sense? This sense. So it will be correct most of the time, and it will be correct exactly most of the time, right? Some guarantee like that I can give, right? And any other function will have a lower guarantee than this. That's clear, right? So
Yes.
somebody asked what is the guarantee, right? So this is the kind of guarantee I can give. But what is the catch here? I have assumed that P star is known. But is P star known? So till here, by the way, is everybody clear with this at least? If P star is
Yeah.
known, how to
Yeah.
compute an answer, how to at least say what is a good
Yes.
answer. All these are
Yeah.
now suddenly clear, right? Previously, was it clear? When I just said something is in my mind, could you even say what is good, what is wrong? No, right? Nothing was clear. But once I say there is a distribution, then you have a definitive answer of what is the correct answer. This is the correct answer. You may not be able to compute it, but you at least know what is your goal. Okay. So that's why modeling assumptions are very important. They actually, drive you towards the guarantees for machine learning. And when you know these goals, you can always tweak your modeling and algorithms to achieve them, right? And what is the pitfall? The pitfall could be your modeling assumptions are wrong. Then what will you do? Then you have to somehow correct them. That we'll talk about later. But at least two things should be clear by today's exercise, that you have to make modeling assumptions. If you don't make, there is no progress, because machine learning problem itself is ill posed. There's no meaning for the problem if you don't give any assumptions. And once you give assumptions, the assumptions may be wrong. That is definitely there. But if the assumptions are right, you can start giving guarantees with probabilistic models, right? And that's why, by the way, this is not the meaning of probabilistic models. Non-probabilistic models also use such probabilities. So we'll come to that later. But see, so you have to use probabilities in order to give some guarantees. So is this clear? I'll tell you how to estimate P star, but is this clear till this point?
So
Yes.
one
Yes.
question I have actually. So how
Okay.
did you come up with this function actually P f of x not equal to y?
So you tell me, right? So what other function quality you would look for? When I already know that there is a joint distribution that is generating samples, I should obviously look for a function that will be most of the time correct. What else can I look for? You give me any other possibility.
So basically, when you say fx not equal to y means you are saying when x is 0, 1 will y cannot be 1, right?
So this is the meaning of this fx. This probability, I'll highlight it with a different. This probability, how do you compute this? Like this. I told you already.
Yes. Mhm.
Right?
Yes.
So if of course my f's so this is how you compute this probability. This you should have learned in school days, right?
Yeah.
Outcome based. Even probability of an event is computed by writing down all outcomes in the event and then adding the probabilities.
But the second one, shouldn't it be x equals to 1, y equals to 0 in that case if fx
No,
not equal
x equal to 1, then what is f of 1? 0.
Okay.
So it is same as probability of y not equal to 0 basically. But what is probability of y not equal to 0? Y equal to 1, right?
Okay.
That's why y equal to 1.
Okay.
Huh?
Okay.
So
No,
yeah,
yeah, I was confused with fx and x actually.
right.
Yeah.
Right. Okay. Now the only question remaining is, so we'll conclude in a few minutes. So how do you get P star? Now, any ideas for getting P star from data?
Sample mean.
Right. Okay. So the answer is that P star can never be got, but P star can be approximated by fraction of times 0, 0 occurs. What is P1? P1 star probability of 0, 0. So instead you simply compute the fraction of times 0, 0 occurs in a large collection of samples. That will be a approximation. And which sense it will be approximation, all that you have to revise. This comes under the purview of law of large numbers. So please go home and revise law of large numbers. It comes in the end of section 2 of the book I was saying, right? So by next class you should be good in section 2 at least, right? Okay. So please revise. And so you know how to compute, not compute, but estimate P stars. From P stars you can estimate your best value of F, right? And what you can show through law of large numbers is, as number of samples tends to infinity, this F hat will go closer and closer to this ideal F star. Okay. Now this is the kind of guarantee which is very, very satisfying, because it mimics the way it happens in human beings. Human beings, what will happen? As experience increases, that is m tends to infinity, that's what we mean by experience increasing, the answer becomes better and better, right? So that's exactly what is happening here, right? So not two birds at one shot, there are multiple birds at one shot if you use probabilities. One is you can start giving meaning to machine learning problem itself. You can start giving guarantees. Thirdly, the important enigma of how you mimic human learning becomes very simple. You just replace human being with a statistical model. You just replace it with a distribution. That's all is the game. And automatically, just because of law of large numbers kind of a thing working, what you will have is, as number of samples increases, the accuracy becomes, the approximation becomes better and better with high probability. Okay. So in machine learning, for human learning, what is the backbone? Maybe you will say the intelligence which is hidden in our brain. But what is the intelligence for machine learning programs? It is as simple as a probabilistic model, that is a distribution, which is being better and better estimated through law of large numbers kind of a result by using samples mean instead of true means. That's all, as simple as that. Okay, so this is exactly what happens. And by the way, whatever I have told you today, it looks like a simple example, but this is all what happens in general in what is called as supervised learning. Okay, so things are a bit more mathematical and formal, but I tried to give you some kind of a essence of what is happening. Okay, so we have, I think, finished our time. So we started Yeah, so I think we have even exceeded by 10 minutes.
Sir, I
So
have
I'll
one
stop
question.
here.
So
Yeah.
can there be a non-deterministic function that can do better than this deterministic function or something like that?
Okay, so that's a good question. But first of all, understand that this is a deterministic function. So such cases where you actually find a deterministic function is called non-probabilistic modeling. Okay. But non-probabilistic models also use probability. Don't think that probability is not there in non-probabilistic models. Non-probabilistic models like SPMs also have this assumptions, distribution assumptions, and that's what makes machine learning meaningful. Now, coming to the question, exact question you asked. Now, can you do better in case of stochastic functions? Right?
Yes.
No. What do you think is the answer?
Well, for this problem, for this set of values, I don't think it can be done, but I do not know the answer actually. Oh.
Anybody else can take a guess? So the answer in general is, see, think about, suppose you have this, so now this set has only 4 functions, right?
Mm.
Now if you increase the number of functions, what will happen? Suppose you have a bigger set which has somehow magically has 5 functions, which includes these 4. Then at least that minimum will be better than this, right? May not be
Yes.
strictly better, but that will not be worse than this.
Mm. Yes.
So one thing is clear, probabilistic models if you introduce, then they won't be worse in this sense, just because the search space is more. But the crucial question is, will they become strictly better?
Mm.
So I'll leave that as food for thought. Okay, so it's a nice question. So think about this. So what's your name?
Money.
Mani. Okay, so Mani asked a very nice question for all of us. So next time, so please think about this and come back with some intuitive answers. I'll try to give you some kind of a justification, but let's see if somebody will come up with an intuitive answer. Okay. But as Mani says, in this case, perhaps it's not improvable, right? That's what Mani's observation is. Let's see, right? So any other questions?
So do we have a class next weekend as there's a
So the entire
convocation?
schedule is given. So there is a class. I am not attending convocation. So there will be a class. You are attending?
No, no, because it's in the schedule. It's mentioned that it's a convocation on 10th of
Yeah,
August.
but that's not affecting us, right? So
Yeah, fine. Thank
okay. Any other question? Okay. So today's class was interesting for me at least. You guys asked nice questions, but I hope the same thing continues when we delve into technical details also. So please keep up this habit of asking questions at regular points of time. Okay. So see you in the next week. Yeah.
So you'll
Yeah.
be sharing the OneNote?
OneNote is already shared. Even you can write now on the same OneNote document, right?
Okay. Okay. Sure.
So please see the OneNote tab which is on your Teams software. And all my lectures will be recorded and they'll be shared with you. So no problem.
Sure. Thanks a
you.
lot.
Thank you.
Yeah.
Thank you,
thanks.
sir.
Bye.
Thank you, sir.
Thank you, sir. Thank you,
Yeah.
sir. Bye.
Bye. Bye.
Thank you, sir. Bye.
Thank you, sir.
Bye.